Hello viewers, welcome to the Advances in Agricultural Engineering course under the annual refresher program in teaching or in ARPIT. This course outline on the sustainable agricultural mechanization, we have covered 6 modules up to now, including the agricultural mechanization. Module 2 and 3 was encompassing the agricultural mechanization situation in the country. Module 4 talked about the agricultural mechanization situation in the Asia and the Pacific region. Module 5 covered agricultural systems and sustainability. Module 6 was considering the performance evaluation of agricultural system. In the 7th module, we are going to talk about the sustainability assessment. This module will comprise energy input in modern agriculture, energy flow in agricultural production system, classification of energy inputs, low input versus high input agriculture, and finally, we will be talking about the key indicators of the performance evaluation, including the concept of eco-efficiency calculation. Here are some of the references that I would recommend the viewers to read through. Starting with the energy input output analysis, which is one of the most important tools in the sustainability assessment, we try to see that how the energy inputs are sprawling everywhere, right from the manufacturing of the farm supplies to the distribution of those farm supplies and inputs, most importantly on the farm production at the site right on the farm itself, to the storage of the produce, then to processing and value addition. That value added or processed food is distributed to the consumers, and last but not the least, part of which is also going to waste as the food waste. So, having reviewed all these steps of the modern agriculture, there are two things which are very much certain. Number one, that this is no longer a subsistence agriculture, but it can be considered as the factory style agriculture in many parts of the world or in many parts of the country. B, energy inputs are very important and significantly contributing to these production process, and that is why the energy budgeting or energy auditing of the agricultural production system is of paramount importance for the modern agricultural scientists or professionals. If we consider the flow of energy in the agricultural production process, there are a number of inputs. May I refer to the controllable or uncontrollable classification of the inputs. So, we are here talking about the controllable inputs, which include human labor, animal labor, agricultural machinery, use of diesel or petrol, irrigation water, seed, important fertilizers, different agrochemicals including the insecticides, herbicides and fungicides, etc. Then we have farm manure and electricity. These inputs, along with the inclusion of the management capabilities or abilities of the farm manager, are undergone different farm operations. These operations may include field preparation, planting, other field operations including irrigation, fertilization, weed control, pest control, and finally to the harvesting. After undergoing these different farm operations, yield is obtained. This might include both the raw grain as well as the straw. This may be expressed in terms of the productivity kg per hectare. We may express the total energy outputs in terms of megajoule per hectare. We can also compute the energy utilized in terms of all the inputs as total energy inputs, once again in megajoule per hectare. This computation of the total energy inputs and total energy outputs per hectare basis can lead to very interesting and meaningful comparison in terms of output input energy ratios, energy productivity or specific energy. Now, this comparison can be made further more meaningful by classifying or auditing different sizes of farms, that may be small farms versus medium farms versus large farms. So, this is the way we can envisage the flow of energy right from the supply of inputs. Even before that, there can be the energy utilized for the production of these inputs to bring those inputs to the farm, then spending the energy in terms of different farm operations, and finally, the energy which is received in terms of the final production. The energy inputs in the agricultural crop production can be classified in a number of ways conveniently. The most understandable and the most convenient, probably the classification is physical energy, that will include the human labor, draft animal, mechanical power which is directly used, or the mechanical power which is in terms of the energy sequestrated. Now, this energy sequestrated is the energy used in the production or manufacturing of those mechanical power sources themselves. The second energy input is the chemical energy, and the third one is the biological energy. The chemical energy is imparted in terms of different agrochemicals, whereas the energy stored inside the seed is considered as the biological energy contribution. Now, further, these energy inputs can be classified or considered as direct or indirect inputs of energy in the agricultural crop production. The direct input of energy will include the physical energy, except the mechanical power energy sequestrated, whereas the indirect energy input will comprise biological energy, chemical energy and the energy sequestrated in the production of the inputs. Based on the uses, the energy can be further classified as the direct energy, which will include the human, animal, electricity, mobile mechanics or the electric power, such as the diesel energy, such as the diesel engines, electric motor, power tiller and tractor. This direct energy may be further classified into renewable energy as well as the non-renewable energy. The renewable energy component will include human, animal, solar and wind energy, fuel wood, agriculture wastes, etc., whereas the non-renewable energy component can be considered as the coal or the fossil fuel. The second part of this classification is the indirect energy, that may be visualized in terms of seed, pesticides, fertilizers, manures or machinery. Further, this indirect energy can be classified into renewable as well as non-renewable energy components. The renewable indirect energy is coming from the seed and manure, whereas the non-renewable part of the indirect energy class is coming from the chemical, fertilizer and machinery. The agriculture in the subsistence world is considered as the low input agriculture, which is a very simple process, where we have got the human interference with agriculture, that is in terms of managing or arranging the resources as inputs. There are different production techniques which the farmers of the world have evolved over the number of years. There is a great sense of community in terms of interactions, and in the presence of the natural forces including the solar energy, these all inputs are then transformed into the internal recycling of nutrients and they result into meaningful production or the yield. This low input agriculture is earthed here symbolically, which means that they are commensurating with the laws of nature, and at the same time they are completing the cycle within themselves. Whereas today's modern agriculture is obviously considered as a high input agriculture, where the inputs remain almost the same: the seeds, nutrient, water, which are the basic inputs anyway, irrespective of what is the level of inputs in the agriculture, but the utilization is to be made linearization of nutrients with the use of heavy technological inputs in order to linearize the inputs of nutrients to maximize the yield. We have got different production techniques, modern production techniques, which might include the heavy uses of tillage practices, pesticides and other agrochemicals, and the human interference which is associated to agriculture has gone many folds, which is symbolically presented with the wider and bolder arrows of these inputs. At the same time, we have been disconnecting our community in terms of the reduced levels of interactions between the society and the agricultural side, which is obviously reflected in terms of the reduced proportion of economically active population and their active participation in the agricultural activities worldwide. This high input agriculture, obviously where there is no earthing, there is no cyclic nature of the input output relationship, and that is why we are today discussing about the sustainability issues in the agricultural production systems. There are different energy ratios in the agriculture. We could talk about the output input ratio versus the endosomatic or exosomatic ratios. Giampietre and Pimentel in early 1990s, they delivered a ratio of the net fossil fuel energy for the agriculture. This assessment allows to look at the fossil fuel input alone and in the ratio to the other inputs. These authors defined two separate forms of energy inputs, namely endosomatic energy and exosomatic energy. The endosomatic energy is generated through the metabolic transformation of food energy into muscle energy in the human body, whereas the exosomatic energy is generated by transforming energy outside of the human body, such as burning gasoline in a tractor. Prior to the Industrial Revolution, virtually 100% of both endosomatic and exosomatic energy were the solar driven. The fossil fuels now represent as high as 90% of the exosomatic energy which is used in the industrialized countries. The typical exosomatic to endosomatic energy ratios of pre-industrial solar powered society was about 4:1. The ratio has now changed tenfold in the developed countries, climbing to 40:1, or in some cases, for example, in the United States, it climbs up to 90:1. The same authors have very meaningfully classified the different factors, including the socio-economic pressure and the demographic pressure, to demonstrate the combined effect of demographic and socio-economic pressures on the environmental loading of agriculture. The gigajoule of the fossil energy input per hectare of cultivated land could be taken as an indicator of environmental loading. In the columns which are representing the socio-economic pressure can be split into high or low pressure. That would resemble the workforce in agriculture. If it is less than 7%, the authors considered as very high socio-economic pressure, because there are very few, relatively fewer number of population which is responsible for the production system. In such economies, the exo to endo ratio is usually more than 30. the labor productivity is very high, usually in the order of more than 200 kilogram of cereal production per hour, whereas the socio-economic pressure is considered to be low, where relatively higher number of workforce is engaged in agriculture, more than 50%. The exosomatic to endosomatic ratio is less than 10 and the labor productivity is somewhat less than the 10 kilogram of cereal per hour. In terms of the two rows, the demographic pressure is further classified into high and low. The demographic pressure is considered to be high, where the arable land per capita is very low, as low which is even lesser than 0.20 hectare. The demographic pressure is considered to be low when there is relatively higher amount of arable land per capita is available. In this case, the authors considered more than 0.75 hectare. At the intersection of these two pressures, the socio-economic pressure is high and the demographic pressure is high. An example country for this kind of situation is Netherlands, where the fossil fuel equivalent of the technical input application are shown in the bold color or in the bold font is very high, and the energy inputs is more than 80 gigajoule per hectare. For the same high socioeconomic pressure, where the demographic pressure is low, for example, in the US, it is medium to low energy input agricultural ecosystems, the energy inputs is around 30 gigajoule per hectare. If we consider the agricultural economies having lower socioeconomic pressure, but at the same time they have got very high demographic pressure, for instance China, they have got medium to high energy inputs to agriculture quoted as about 50 gigajoule per hectare. For the same low socioeconomic pressure and the low demographic pressure, these are the traditional or subsistence economies where the fossil fuel input to agriculture is very low, which is in the range of very few gigajoule per hectare. So, that is why we can show the combined effect of demographic as well as the socio-economic pressure on the environmental loading of agriculture. The vast majority of endosomatic energy is no longer expended to deliver power for direct economic process. Now, the majority of endosomatic energy is utilized to generate the flow of information, directing the flow of exosomatic energy in terms of driving the machines. Considering the 90:1 exo to endo energy ratios in the United States, each endosomatic kilocalorie of energy expended in the United States includes the circulation of about 90 kilocalorie of the exosomatic energy. Therefore, the US food system, for instance, consumes 10 times more energy than it produces in terms of the food energy. In today's agriculture, about 10 kilocalorie of exosomatic energy is required to produce 1 kilocalorie of food which is delivered to its consumers in the economies like US food system. This energy includes the packaging and all the delivery expenses, but excludes household cooking. The heavily mechanized agricultural systems are using approximately 1000 liters of oil to produce food from 1 hectare piece of land. With the discussion on the different classes and classifications of energy, now let us talk about some of the major indicators which could be used to determine the performance of this agricultural production system, mechanized agricultural production system. We may start with the output input ratio, which is simply expressed as the energy output as a megajoule per hectare to the energy input again in megajoule per hectare, and that ratio becomes unitless. Energy productivity, which is expressed in kilogram of the megajoule, is the ratio of product output in kg per hectare to the energy input in megajoule per hectare. The specific energy is the reciprocal of the energy productivity, and is expressed as megajoule per kilogram, which is the energy input in megajoule per hectare to the product output in kg per hectare. Similarly, the net energy can be computed by subtracting the energy inputs in megajoule per hectare from the output energy again in megajoule per hectare. The greenhouse gases emissions can be expressed in tons of CO2 equivalent per hectare per year basis. To analyze the energy, we can go for the calculation of direct energy inputs. There are few of the equations. Number 1 is the direct energy input of human labor, whereas E human expressed in megajoule per hectare can be computed by the number of human laborers employed in agricultural task multiplied by the time required to conduct that operation multiplied by energy equivalent of human labor divided by the area on which the human labor is employed for work. Similarly, the direct energy input of the draft animal can be computed as the power equivalent of the animal multiplied by the time divided by the area on which the draft animals are utilized, and this energy is again expressed in terms of megajoule per hectare. Third is the direct energy input of the fuel combustion, which can be expressed as E fuel in megajoule per hectare, which is the average uses of the fuel multiplied by the specific energy coming from that fuel multiplied by the time divided by the area. After computation of the direct energy inputs, the indirect energy inputs can further be calculated in this way. The indirect energy input of agricultural machinery is the E machinery in megajoule per hectare, which is calculated as the weight of the machinery multiplied by the energy demand for production of each kilogram of the machinery divided by the service life of that produced machinery multiplied by the time and then dividing it by the area on which this agricultural machinery is being utilized. Indirect energy input of chemical energy, that will include the fertilizer, pesticides and herbicides, will then be calculated as the rate multiplied by the input of those chemicals multiplied by the time. The indirect energy input of biological energy, which is in terms of seed, can be expressed as the E seed in megajoule per hectare equal to the weight of seeds multiplied by the energy equivalent of the seeds and dividing it altogether by the area on which these seeds have been spread. Finally, the eco-efficiency is the common elements of eco-efficient farming definition in the concept of sustainability, which will include the concerns with the sustainable and efficient utilization of farm operation resources. It includes the improved level of production using of less resources and less losses to the environment. It is related to the efficient utilization of energy, plant nutrients and pesticides. It is involved with minimizing the amount of greenhouse gas emissions. This concept suggests that the eco-efficiency is a ratio of economic value to the environmental pressure or the damage and can be expressed as eco-efficiency in the monetary terms divided by the tons of carbon dioxide equivalent per unit area, which is equal to the economic value in monetary terms dividing it by the environmental damage, which is expressed in terms of the tons of CO2 equivalent per unit area. Thank you very much.